Good morning, good afternoon, or good evening. I'm Luke Upton, editor and co-founder of Biomarket Insights, and I'm delighted that you can join us today for a very special broadcast in partnership with Axens, technology for fulfilling the promise of advanced bioethanol. Now, when we in Axens were discussing this webinar some weeks ago, I was delighted when they came up with the phrase fulfilling the promise to be in the title, as bioethanol, like so much in the bioeconomy, whilst already showing lots of promise, and there's some great stories out there, there's still work to do. And there's no one better than Axens, and in particular the two experts joining us today, Varun Ginotra, Business Development, Renewable Business Group, and Larissa Perotta, Technology Team Manager, Biobased Technologies, to guide us through this exciting opportunity with their own practical advice, insight, and wise words in this really exciting area of the bioeconomy. But first, before I hand over to the experts, a little bit of troubleshooting, just in the unlikely event that some of you encounter any issues. So if you are having problems watching or listening, please close down any apps in the background, so Teams or Skype, etc., as this can sometimes use the bandwidth that you need. If you're using a VPN, please turn that off. Chrome is the best browser. If you're still having problems, please try swapping connections, so from wired to wireless or wireless to wired, or using a different network, so a home to mobile hotspot, etc. And if all this fails, please try a mobile device or iPad, as this is a different stream type. And remember, all of this is being recorded and will be available as an on-demand broadcast as well. So if you get called away halfway through, or you have colleagues who you think would like to watch after the broadcast, we'll have the link ready for you, and you can share that. As you'll know from having watched our webinars throughout 2020, engagement is at the heart of everything that we do. So we have plenty of time for questions at the end, and there's some boxes on the side there, so please fill in your questions as we go through, and Larissa and Varun will be happy to answer at the end. But before we begin, a quick poll from us. As always, we like to gauge the health of the bioeconomy and how you're feeling about it all. So a quick question coming out to you all right now. And it is quite simply, how do you feel right now about the future of the bioeconomy? So right now in the afternoon or the morning or the evening of the 15th of October, how do you feel? So it's positive, significantly more positive, about the same, less positive, or worried. So just put your answer in there. Always useful for us to see how people are feeling about everything. So how do you feel right now about the future of the bioeconomy? So significantly more positive, positive, about the same, less positive, or worried. So please just put that in there. Thank you very much. That's enough from me. I'll be back later on for the Q&A. Make sure you ask them all the way through. We've got a couple of real experts here today, so please ask away. They're happy to answer anything you have. So without further ado, I'm very happy to hand over to Varun. So Varun, over to you.
Okay, thanks, Luke. Good morning, afternoon, good evening to all of you, and thank you for joining us today for the first webinar in the Biofuel and Biochemical series in cooperation with Biomarket Insights. We are happy to kick off the first webinar on the technology for fulfilling the promise of advanced bioethanol. As you know, my name is Varun Ginotra. I am accompanied by my colleague Larissa Perotta. So let's start first with a little introduction about Axens. Axens is one of the world leading process technology provider, which is backed by a strong R&D and its innovation. We manufacture more than 70,000 tons of catalyst and adsorbent every year for our clients worldwide. With the recent acquisition of Ferté Petrochem and Prozonat, we also deliver equipment and modular units. We have more than 500 references for these modular units as well. Axens Group activities are covering mainly 5 big markets. It's oil refining, petrochemical, gases, alternative and renewables, and water. Our today's presentation will deal mainly with the renewable sector within Axens. Okay, in today's day and age, the path of decarbonization or green economy goes through the key ingredients of biofuel and bio-based polymers. In Axens, this is also the path we chose to move towards the green economy or the bioeconomy. However, this path is not straightforward. It's a rather long process where you require different expertise and deep knowledge of biomass, expertise and knowledge on equipment and biotechnologies, also knowledge on new catalysts to be developed for bio-based technologies, as well as the knowledge of the operations of these technology at an industrial scale. And last but not the least, having sound and right analytical tools to evaluate each step is also key for having reliable and robust technologies. However, in order to shorten this long and time-consuming path, there is a short way, and the short way is by partnering with some industrial players. Thanks to the partnership with 12 industrial players, Axens has developed new technologies in the biofuel and biochemical sector. Now, because of this partnership, I would say Axens has possibly the world's largest portfolio for biofuel and biochemical production. Well, I can give a quick overview of these technologies to you just now. Let me first start with vegan. Vegan is the technology for the hydrotreatment of oils and fats to make renewable diesel. Renewable diesel can also be made through an alternate process by gasification of biomass, followed by Fischer-Tropsch, and these technologies are called Bioethanol and Gacel. Further, Futurol is the enzymatic conversion of the biomasses to make cellulosic ethanol. And this is actually the topic for today's webinar. If we move towards biochemical, the ethanol can be further dehydrated to make bioethylene through the technology called ethanol, and the ethanol can be the first generation ethanol or advanced ethanol. BioButterfly and BioTCAT are the two technologies which are currently under development, and the objective for these technologies is to make biobutadiene and bioaromatics. These technologies will be available in the commercial domain in the next 2 to 3 years. Now, if we look at Futurol technology for the production of biofuel, production of bioethanol, the development started back in 2008, where more than 100 researchers were working at 13 R&D facilities across France. This development of technology had strong financial backing as well as backing from 11 market-leading players. The objective for this development was to create a simple and integrated cellulosic ethanol production technology. Now, speaking of partners, the strength of the technology is delivered from the major R&D players, which are specialized in their own domain. And these 4 R&D players are INRA, which is the French Public Research on Agriculture. They brought the expertise of biomass development and transformation. LESARF, they are a global player in the biocatalyst development. IFPN, which is the mother company of Axens, as well as a strong R&D institute with long history in process and technology development. Last but not least, ARD, which is a major player in the industrialization of biotechnologies. Futurol brought the best experts together to jointly develop and bring to market this wonderful technology called Futurol. With all the strong R&D work, we developed a pre-commercial plant back in 2011 in Pomac in France. And the capacity for this plant was more than 100,000 liters of ethanol per year. This plant, which has a full process chain from feed pre-treatment to final ethanol product recovery, helped us to constantly enhance the portfolio in different biomass, as well as act as a technology platform for future development. In addition to this pre-commercial plant, we set up a 100 ton per day industrial demo to validate and scale up the technology and demonstrate the readiness to the market. On this slide, you can see some of the pictures of this industrial demo plant. Well, both these pre-commercial as well as the industrial demo plant are currently under operation, and we'll be happy to take all our clients for a visit to both of them if they choose to, and we'll be happy to showcase what we are doing. Actually, I have a video in the next slide, which is going to show more on the Futurol technology as well as the development of the pilot to the industrial scale. Over to the video. In this video, you saw how we went from the demo scale, from the pre-commercial scale to the demo scale, and also the people which were involved in the development of the Futurol technology. Further, I'm happy to announce that with the hard work of our team, Axens has been successful in licensing a commercial plant of 55,000 tons per annum of cellulosic ethanol to INA refinery in Croatia. The PDP for this project has been completed, and this project is going to be the flagship project with one of the highest greenhouse gas emission savings in the Europe and possibly in the world. Now I hand over to my colleague Larissa, who's going to speak more on the Futurol technology and get into the details of the robustness of the technology. Over to you, Larissa.
Thank you, Varun. So good morning, good afternoon, good evening, everybody. So you've seen a little bit of the story of Futurol, how it was born and where we are today. Let's now take a look on what's behind it, what's the result of this story in terms of technology. So Futurol is a four-step technology. It starts with lignocellulosic biomass to produce cellulosic ethanol, and it starts with a very first step of pretreatment of this biomass. Here for us, it means standardization. This is the word to keep for the biomass pretreatment. We're going to have more or less the same output from the unit, whatever the biomass you're feeding to the unit. It will be a solid which presents low moisture content, high C5 sugar yield, and very interesting and high cellulose digestibility. Once we have this pretreated biomass, then we're going to diverge a small amount of it to step number 2, one of the pilots of Futuro, biocatalyst production. On Futuro, we rely on on-site production of our biocatalysts, both enzymes and yeast, which are also tailor-made, and by growing on the substrates they are going to see later on, they are fully adapted to it and present high resistance to any potential inhibitors. We have our biomass, we have our catalysts, we just need to put them together on step number 3 and produce the ethanol. So step number 3, hydrolysis and fermentation. It's a one-pot process for us, which means we put everything together at T0 in order really to save capex and opex and have maximum sugars conversion. Once we have our wine or fermentation broth, then we just need to separate it on step number 4, products recovery, where we're going to recover the lignin for steam and power production, and also recycle the water with or without treatment, depending on the final use. So, in a nutshell, how to fulfill this promise of bioethanol? For us, it really relies on 4 main pieces of a puzzle: multi-feedstock process, high conversion performance, robust and efficient biocatalysts, and simple, efficient, and integrated process. If we take the first piece, multi-feedstock process, biomass-based units really depend strongly on local availability of biomass, on crop cycles for the stability of composition, complex logistics, and also biomass is quite often the source of unit size limitations for those kind of units. So one of the big premises of R&D since the beginning in Futuro was that from an R&D point of view, in order to prove that the technology is scalable anywhere, but also from an industrial reality point of view, let's say, we said that we needed to develop from the beginning a highly flexible installations in order really to reduce storage, take advantage and be able to adapt to any feedstock opportunities that you may find. Translated this into the R&D strategy, that means we worked a lot on the biomass portfolio, testing and validation of different biomasses, and also, as I said before, biomass standardization. On the portfolio side, from the very beginning, we started with 3 pieces of biomass, representative of different groups of biomasses: wheat straw, miscanthus, and also wood. We developed the technology on that, and then basically, as they were extremes of different biomasses in terms of density, rheology, and any other behaviors, what we did afterwards were really to confirm that the technology developed on those ones was applicable to all the others. And for that, we've validated all the performances in our demonstration plant in order to provide performance guarantees on a wide range of biomasses, which can be found a little bit everywhere in the world. So today we have not only tested those 3, but also expanded the portfolio to biomasses that we may find in Asia, in America, and not only in Europe, as in the beginning. Today we have, for instance, all the biomasses that are shown over here, and of course many others being tested in the pilot plant at this right moment. And one information here also is that, of course, any biomass that you may have in mind is possible to be treated in the pilot plant as well. And how can we ensure that our process is feedstock flexible? This is the second big point of R&D, standardization. As I said before, the pretreatment here is really all about taking the same biomass at the outlet so that it can be easily processed downstream. Second point is working on biocatalysts. As I said before, Futuro relies on on-site production and propagation with tailor-made catalysts that are produced on the biomass they're going to convert downstreams. Having those 2 points, other 2 steps just needed to be adapted and having enough flexibility in order to treat everything that may come from those 2 first steps. So it's a matter of good design practices. Second piece of the puzzle, biocatalysts. Here we have 2 important points. The catalyst itself. They are tailor-made for best performance. They present outstanding resistance to inhibitors, and of course they benefit from continuous development of our both catalyst suppliers, which are shown here. Fungi are supplied by IFP Energie Nouvelle, which is our mother company, in order to produce the enzymes on site, and we rely on Leaf, which is a company from Le Savre, partner of Futuro project, to provide the yeast for this technology. Second big step, on-site integrated production. And this is really for cost minimization, improved logistics, but most of all, really to rely on no latency on the downstream processes. We are what we eat. This is also worth, and the same for biocatalysts. So they can process very easily any feedstock they've grown on during the catalyst production step. And then what's the result of it? Basically, the result of it is seen downstream on a process with high conversion performances. As I mentioned before, we rely on a one-pot process, which means we start at T0 with enzymes and yeast in the same pot. You can see here in the graph what happens during a batch of fermentation. Basically, sugar's concentration, which is the reddish color here, is nearly zero during the whole batch. Ethanol concentration increases during the whole batch as well. What does that mean? That means that basically we have a simultaneous saccharification followed by co-fermentation of sugars. And this is really a strategy to minimize contamination, as we have no free sugars that remain for some time inside the fermenter, as well as to push higher the enzymes activity, as they are not inhibited by the sugars that are released from the biomass. With this, we ensure that we can convert all the sugars and also all the cellulose, which is there to be converted by the enzymes, maximizing the ethanol yields that you may have in the process. All this leads then us to the final piece of our puzzle, integration. Fine-tuning and correctly agencing all the strengths of Futuro leads to a simple, efficient, and integrated process. The idea here is really to take all the interesting data that we got and put them together in order to maximize time on stream, reliability of the units, energy self-sufficiency with co-products valorization, and also maximum recycles in order to get to a zero liquid discharge technology. What we can see here in the graph is just an example of the order of magnitude of improvements that you may expect to have with, for instance, from one version to the process to the other. And this relies mainly on integration and biocatalyst improvement that will happen all over the time in a continuous basis. So, now that you know Futuro a little better, and before we conclude the presentation, let's talk a little more about the future and what's next. Today, Futuro allows you to get access to cellulosic ethanol, and this is already a big step in terms of GNG emissions, and all the trends that we have in order to move to a green to the green path that Varun showed you before. But we don't stop there. Futuro also opens the gate to new green chemistry through the second generation sugars. With futurol, basically taking a few steps and adapting the futurol technology, we can get access to second generation sugars technology, which is basically the source of valuable platform molecules. It opens the way to different chemical intermediates and different molecules like alcohols, monomers, acids, and other applications, not only biofuels. How does it happen? We're going to keep the very two steps of futurol that were already presented. We've taken the proven pretreatment technology from futurol, proven enzymes production from futurol. Same enzymes, which means you will be benefiting also from constant stream optimization that you will have on futurol. And then at this step, we're going to adapt the scheme. We're not going to produce ethanol, so the one-pot process may be adapted in order to perform hydrolysis only. And with this hydrolysis, after some separation, you can directly get access to a mixture of C5 and C6 sugars. This is already very interesting, but of course, if you want to go further, one step further, we can also get access to separate streams of sugars, C5 and C6, with additional sugars concentration and purification steps. So, in order to summarize, futurol today fulfills the promise of bioethanol. You've seen it's a technology which will be in industrial operation very soon, and we're quite happy for that. It's a feedstock flexible process adapted to any campaign operation to take advantage of different biomasses, optimized and integrated process with a very robust and strong background, more than 10 years of R&D, which still continues. And of course, it opens the way to the new green chemistry, the second generation sugars. Thank you very much.
Thank you.
Thank you very much, Larissa and Varun, for a great introduction there. So we've got some questions coming in already, but please feel free to keep asking away in the corner in the attendee questions there. Quick question from us though before we get to your questions. So again, we're always interested to hear, learn a bit more about our audience and what you're doing. So a quick question coming out to you right now. Is your organization currently looking to set up a commercial cellulosic ethanol plant? So yes, we're aiming to in the next 12 months. We hope to, but not exactly sure when, or no. So question coming out to you right now. So if I can get everyone just clicking where they are on that, that would be great. So is your organization currently looking to set up a commercial cellulosic ethanol plant? So yes, we are aiming to in the next 12 months. We hope to, but not exactly sure when, or no. So if you could answer that, that would be great. Thank you very much. And yeah, first question then. So first question coming in here from Gary Hilberg of Continuum Energy, of which he's the president. So what is the net efficiency of the process versus traditional core-based ethanol? So what is the net efficiency of the process versus traditional core-based ethanol? So I don't know who wants to take that question on.
Yeah, I'll try to take it, let's say. Basically, well, the corn ethanol, it's a 1G, and of course, we're going to add one step regarding to 1G here. When we talk about the cellulosic ethanol, we'll add a pretreatment and hydrolysis step. So basically, of course, in terms of yield, you need to access those sugars which are not free, right? So for that, you will pay a little bit. You add an extra step for sure. So what I can say today is that typically, it depends on the biomass for sure, but typically it's possible to ferment, let's say between more than 80% of all the sugars, the potential sugars that you can get on that biomass, which means from cellulose and hemicellulose that you can get on that biomass.
Okay, thank you. A question coming in here by text. It's for I think it's for Varun. It was in your part of the presentation. Saying very impressive list of partners that you featured on one of your earlier slides. Could you give us an indication of the timelines of when these partners were gathered, and any advice for working with such varied big companies?
Okay, so I guess the question is specific on the Futurol, if I'm not wrong.
Yes, I think so. Yeah, I think it was one of the earlier slides, wasn't it?
Okay, maybe I can start to answer, and I'll let Larissa fill in to add some extra points. So, like I said, back in 2008, all the partners came together, and they came together to start talking about the Futurol process and the development of it. And of course, maybe 1 year or even before that, all the partners have started talking to each other and started conceptualizing that we need to make a special group with the consortium of industrial partners as well as the R&D partners, which will start working from 2008. So let's say a timeline of 1 year before the actual start of R&D work would be the timeline when everybody started, talking to each other and came together to form a consortium.
Yeah, and maybe I'm not sure. Well, this is also a typical timeline that we observed for the other projects. I mean, the very second or third slide when we showed all the technologies and the fact that we partnered to pretty much all the technologies in order to put them into the market. This is typically what happens. Yeah, we start discussions, and let's say in roughly 1 year you can start and kick off the project, the R&D, the common R&D.
Okay, thank you very much. Lots of questions coming on in here, which is great. A question here from Peter Flippo from the Bioprocess Pilot Facility. Hello, Peter. He was a presenter, I think 2 or 3 weeks ago on one of our other webinars. So glad you could join us today. How would you benchmark technical or financial Futurol to the POET process? So how would you benchmark technical or financial Futurol to the POET process?
That's a tricky question, actually, but a very interesting one, and I could spend hours talking about it. Basically, we don't have exactly the very same arrangement of very same steps in the technology, not exactly the very same ways of doing things, let's say like this. I think that Futurol, we took longer to come to the market compared to this technology. And this was quite interesting for us because we could also see what was going on and what was happening in the world with all the technologies that were popping up. So I would say that we took our time in order to put in the market a technology that wouldn't necessarily have the same difficulties that were observed in 2014 with many technologies. So we took our time to put in place 100 tons per day plant in order to pre-treat the biomass, and this is a big and strong point of Futurol. I think it's the only demo plant with this size, and it was really built for R&D purposes. And I was one of the people operating this plant for a few months, and it was an incredible and amazing experience. And so basically what I would say is that we worked on the pre-treatment because we saw it was very critical step. And the second step that we worked on was the enzymes, and specifically on-site enzymes in order to get feasible projects with economics in order to get it really to an industrial reality. So I would say that these are the two big points that make a difference regarding future or comparing to most of the technologies we could see popping up in the past.
Okay, thank you. Yeah, big question there. A question here from Alez Book, who we know well. How do you see the ethanol market in Europe for biofuels? Is there a future besides the developments in Brazil and US? So I guess looking at the market here in Europe and comparing to that in North and South America.
Well, let me answer this question. Of course, with the RED II regulation, there is a requirement of the amount of blending to be done of advanced biofuels in the overall pool in the European Union. So we see there is going to be a strong demand for these second generation plants in the European Union, and we are already seeing a lot of traction. A lot of clients are talking to us. We have the first commercial plant in Europe, and there are several other activities happening in Europe as well. So the demand, based on our projections, are going to continue for the next 5 to 10 years, and of course, compared to the other markets, the regulation is more mature. Of course, in US it's also mature, but compared to other markets, it's more mature. So that's why there is a strong incentive and strong push across the board to move towards these bioethanol or cellulosic ethanol plants. But having said that, we feel it's not just Europe. I mean, there is going to be another wave which is going to come in the other parts of the world, especially in Asia. Of course, Brazil is doing already a lot of work in bioethanol. US, even though US is a little bullish on the ethanol side, but we still feel there is going to be down the line a lot of projects which will come there.
Okay, thank you. A question here from Zander de Jong, who's with the Kuwait Petroleum International, where he's the principal process engineer. Thanks for watching, Zander. A question here on feedstock. What is the range of possible feedstock? Only wood type of waste you mentioned on page 14, or also on waste like citrus peel? So the range of possible feedstocks and possible waste feedstocks.
Well, to be honest, any feedstock which has cellulose, hemicellulose, and lignin, which is anything which is found in the nature, linked to bio, is going to be a potential feedstock. On the slide, we have shown some of the feedstock which we have already tested. We have done lots of campaigns, and we are 100% confirmed, guarantee that this is going to work and can provide guarantees. But we are constantly, testing new feeds. And if there is a need for a new feedstock, we'll be happy to take that feed in our pilot plant, do some campaigns, show the results very transparently to the client, and even give them the product if they want to take back ethanol, lignin, or any byproduct. So making the answer short, the feedstock is a potential feedstock which is mentioned. We will be happy to take a sample of it and do some analysis and provide you the estimates on the yield and the potential for it. So happy to take it further after this webinar.
Thank you. And just to let everyone know, we've got lots of questions coming in, which is great. But we'll pass all these questions on with your details to Varun and Larissa after we're finished here. So they'll follow up with more detail. We're getting it's a couple of questions on price here. So a question from Hank Vleeming, Process Design Center, where he's the CTO. He's asking, can 2G ethanol produced with futurol compete with 1G ethanol, and what would be needed to make it price competitive? We've got a sort of similar question on the price from Jean-Yves Dupré of BioThink. So question on cost and cost effectiveness or competitiveness.
Yeah, well, one of the big steps in order to start in this world is biomass. What makes the price here, of course, as I said, you're going to add an extra step with, comparing to 1G. So the big advantage of these technologies is because the feedstock that you get is less expensive than 1G feedstock. Some of them are residues. Some of them are not really priced today, and people get paid to remove them from the field and things like this. Of course, for projects like with those feedstocks, we will have very interesting economics. And so basically, I would say we've made everything we can, and we're still working on improving every time the competitivity of the process. And this means mostly biocatalysts. To be honest, it's the enzymes and the yeast that make a big part of the conversion. And we brought them to on-site production in order to make this economic. The second step to work on is biomass sourcing, pricing, and securing it, which is also why then, as I said before, we ensure to have the flexibility to take any opportunity, to be able to switch from one biomass to the other, and not only to rely on one source that, of course, may have its price evolving in time as people get to realize that it's starting to get an interest, right? So it starts to increase the price also.
Thank you. Noah Hirsch, the CEO at ETB, also asked a similar question there about price. Thank you, Noah. I hope you got a bit of an answer there. Question coming in here from Alexei Lira, a chemical engineer at Intervep. So thank you, Alexei. Asking about what is the feedstock conversion and what do you do with the unconverted product?
Yeah, as I said before, you're going to convert quite easily more than 80% of the sugars that you find in biomass. Of course, when I say more than 80%, it's because it depends on the biomass. If you have wood, conversion is a little bit more difficult than if you have very easily accessible sugars in a biomass. What you get from the rest of it is basically some unconverted refractory cellulose and also the lignin. Lignin in futuro, it's recovered at the end of the process. If you're talking about a standalone plant, it can be burned in order to produce power and steam. But actually, within futuro, at the battery limits of futuro, you may also recover this lignin to do something else in terms of conversion. So it depends really on the strategy that you could have behind the project and how far you want to go in this bioconversion and what kind of other energy sources that you may have in order to balance this all.
Thank you. And a sort of similar question, or a continuation perhaps of the question, just come in from Piet Wagner, who former process engineer at the Zeeland refinery in the Netherlands, asking where do the impurities like potassium end up? Is there a solid waste stream, and if so, what can be done with it?
Well, part of it, basically, you have two residues in the outlet of futuro. You will have the lignin, which may have some of these ashes, and you also have the vinasses, which can, depending again on the strategy of the project, which can be treated and recycled to the process in terms of water, and then you have some solid residue that could also be burned together with the lignin, or it could also be that you use this stillage, this vinasse, as a fertilizer. So it will depend on the strategy once again. I don't know if you want to complete on something, Varun?
No, I think it's like Larissa was saying, there are several options for the valorization of the byproduct. I mean, one is stillage, which can be valorized into stillage of vinasse, which can be valorized into biogas.
Also, yeah.
And this could be, I mean, termed as a renewable biogas, and will be priced, of course, at a much premium compared to other routes. And lignin, I mean, there are several options for lignin. The easy one is, of course, to burn and make steam and power, and there's a lot of other than that, there is a lot of work going on for lignin valorization into more specialty products. There's a lot of work being done in Europe. Axens and its partner are also looking at these routes with some of the potential companies. So what we are trying to say here is, even though ethanol is one of the primary goal, but the overall economics, the bioeconomics is done when we are valorizing the side products, and Axens is one of the partners which is doing a lot of work with this and along with this R&D partners to make sure that each molecule or each byproduct is giving out the maximum premium to the end client and have the best economics for the project.
Okay, thank you. I feel a bit like I'm conducting a job interview here with all these questions. They are all flying in from our audience, so that's a good sign that people are interested in that. But slightly different question here. Maybe we move away a little more from some of the technical aspects. But a question from Kauthar Zafuri. Apologies if I've not pronounced your first name correct there. Who's CEO and founder of a Green Energy Solution. And asking about which is the main challenge in terms of marketing bioethanol processes, the constant availability of the feedstock or the competition with the oil market?
I would say that basically with those two options of answer, you've actually answered part of your own question. There are two things here, of course. If we talk about going green, quite generally, let's say, the competition with oil companies comes a little bit. At least what we see today in our portfolio is that the quick decision, the easy decision, is maybe to go as an immediate way of showing that you're going green and working on the future. Is maybe to go for technologies like the vegan technology that we have for HVO. It's quite easy to adapt and quite easy to this kind of industry. Once you've made this step, then people start looking to what's behind, what else we can do and how we can do better, because these kind of technologies here, like Futurol, the greenhouse gases emissions, they're not comparable to what you have for vegan. Vegan, you may, depending on the feedstock, be in difficulties for the red two, for instance, whereas here you have 90% plus reduction. So it's really a game changer. But of course, it's a different step. So we need also to understand that the movement comes a little later than other technologies, and this is what we're experiencing, I would say. And then biomass availability for sure is one of the things that retrain a little bit people, because we need to investigate this point before checking the technologies in order to make sure that we have enough biomass and have you can have your economics with the size of plants and things like this, which is also something to be done, but of course nothing that will stop and prevent the technology from expanding, right? It's just that these are new skills and we need to dig in a little bit.
Okay, thank you. I've got a few. Varun?
Yeah.
Did you have something to add?
No, it's absolutely fine. No, it's fine.
Okay, we've got a few questions coming in on very specific pricing or quantities, and I'll just pass. They'll go over to the team after the broadcast, and they can be followed up with you directly.
Luke, on the pricing and the support on project development, Axens is very much keen to help our future clients to set up the right location, the right feedstock for not only Futurol but other bio-related processes. You cannot have one solution of Futurol for your sustainability or decarbonization needs. So that's why I'm saying if there is a real need of requirement to go towards sustainability, biofuels, biochemicals, we have the biggest portfolio. We can support on the biomass supply chain, and all those logistical issues can also be addressed with the support of our team in-house. So really, I know these kind of challenges and these kind of questions comes to the mind of every client. But to address that, Axens would be very much keen to support and do some sort of a hand holding if needed.
Thank you. I'm sure some of our viewers will be happy to have that conversation with you after this hour. A question here from Per Norlin, who works for Valmet. How do you look upon the fractionation of furfural and the market for furfural? So that's the liquid in resin manufacture. So any thoughts on that?
I'm not really sure I understood the question. I mean, the furfural, the co-product that you may get and conversion of this, or the furfural that we may form in the process. Of course, the furfural we may form in the process, we really actually try to avoid it because it's a potential inhibitor for the fermentation processes that we have downstream. So this one we try to avoid. If we're talking about the furfural that you may have as a side stream from other processes, what I can say today is that this is part of things that we investigate with our mother company mostly, in order really to develop applications and technologies for that. And of course, we'll be happy to follow up and discuss a little bit on that.
Thank you. Question here from Ganesh Nayak from Exter and Corp. Thanks for watching, Ganesh. Are you open to licensing biofuels technology to new potential partners?
Well, absolutely. I mean, this is our business model. I mean, we are licensing all our technologies to the clients worldwide. And as I mentioned, Futurol has already been licensed to one of our refiners in Europe, which is INA. Apart from that, for the HVO technology, vegan, we have also licensed a couple of units. Some of them are in the public domain, and some of them are still confidential. So this is the bread and butter. This is the business model of Axens, to license, and we'll be happy to work with Extra.
Okay, thank you. I'll pass those details on. Question here from Magdalena Ionita, who is head of technical development at OMV Petrom, asking you very simply, how would your technology differentiate from ones of your competitors?
Well, I think basically the four puzzle pieces that I put together are a big way to summarize this. It's if you have to keep one word, is standardization in order to maximize conversion. This is really what's behind Futurol. We try to take the maximum from the biomass and from any biomass, which means really standardizing it in order to be able to treat it. So two big words is flexibility and yield. And of course, then behind it, it's mostly one big pillar is the biocatalyst on-site production, which really is a must for us in order to keep economic feasibility.
Okay, thank you.
Just to add a little bit more on Larissa's point. I mean, you saw the partners. I mean, we have the four key partners which are expert in their field, and when you have four big partners which are experts, they all, you have a group which you cannot beat. So we take the best from everybody and then bring it on the table. So I believe the others do not have, and this is something which differentiates us compared to the competition.
Okay, thank you. Just time, I think, for just two more questions. We've talked a little bit about price already. We've had a few questions on it. But a question here from Rob Beakers of Cargill. He's a director of business development. So thanks for watching, Rob. And his question is, how does the cost of the futurol ethanol compare to the cost of sugarcane ethanol in Brazil or corn-based ethanol in North America?
Well, coming back to the answer I just said earlier, of course it depends on the biomass. I would say that if you have a biomass that is around, let's say, 50 euros per ton, 50, 60 euros per ton, you will get competitive with 1G ethanol. I don't know if it's. Please come back to us if you want to discuss a little further. But this is a quick indication, a rule of thumb like this.
Okay. Yeah, absolutely. So that there's some quite complex questions coming in here, and I'm sure you can follow up directly afterwards. Just time for one final question here. So it's from Ales Buch again, but it's quite an interesting one because it's looking a little bit at the wider industry. Asking if biofuels are an intermediate step towards a biochemistry future, or is there a sustainable future for biofuels in Europe? So, question on the growth of biochemistry or the growth of biofuels.
Okay, so let me try to answer this, and Larissa can pitch in. Well, I would see both the biofuel and the future biochemicals to go hand in hand. Of course, there are regulations which require us to fulfill the volumetric or let's say the blending targets. But on a short-term point of view, if I make the answer short, on a short-term point of view, biofuels are going to be the key elements. On a long-term point of view, if you have to have a more economic and a proper green economy and a bioeconomy, coming back to your first question, we have to integrate both the elements of fuel and fuels and the further derivatives together to really make it a successful bioeconomy.
Yeah, I agree. I think biofuels are there, and they will launch. They are launching the whole industry, and what we see is that once this step is done, basically. You start looking to the next one, and the next one for sure are the bio-based chemicals, and we're working a lot on that with the second generation sugars platform. Basically, the amount of technologies that you can imagine, bioconversion or catalytic conversion from those sugars to different molecules, is just endless, right? So, for sure, the entrance point is biofuels, but we're not stopping there.
Okay, thank you. I think that's a good place to stop with 1 minute left. To Murianto, Silas, Marcin, Jean-Yves, Fernando, Philippe, and Anna. Apologies, we've not got to your questions, but they will all be passed on to Varun and Larissa as soon as we're finished here, and I'm sure they will follow up. But been fantastic array of questions here. A really good mix of viewpoints, and I can see people are really engaged with this area. So that's great. So I don't know if there's any final words from Larissa or Varun before we close.
Well, the final words are the same which we just mentioned. The biofuels and the bioeconomy is going to be the future. You have a partner in Axens which is there with you, and have a long-term vision with not just with fuels, with biochemicals. So it's going to stay, and you have a partner which is going to stay with you as well. Great.
Well, thank you very much, both of you, for joining us this afternoon. I'm sure Axens will follow up afterwards, but if you didn't get round to pinging in any questions, or you have anything that you think of afterwards, feel free to email me, so Luke, Luke, at biomarketinsights.com, and I will be sure to share your question or observation with Varun or Larissa. But huge thank you to everyone who's joined us today. We've got a really exciting program of webinars on at the moment, so visit biomarketinsights.com to see more. Our friends at Axens will be back for another webinar at the start of 2021, so we'll be sure to let you know about that. But again, a big thank you to Varun and Larissa for joining us today, and a big thank you to everyone who joined us today and asked some questions. And as I said, if you haven't had them answered, they'll all be shared afterwards, and the team there can follow up. So thanks again for joining us, and we look forward to seeing you again at a broadcast very soon. So.